Okay, hello everyone. Um, so we want to simulate a very simple circuit here today in EDS. The first thing we need to do is trying to open. If we have a workspace, we open it. If we don't have it, we make it. So I consider we don't have anything. We assume we don't have anything. So first we need to show up the software, advanced design system. You click on it and you wait, go with the first license. Okay, then we want to create a new workspace. So we click on this. You can put any name on the workspace. We can put it, for example, build 2020. And this is where you save your workspace. So change it to your H drive, but I'm gonna save it here in my C drive because I'm using my the computer in my office. But you can use RD machines to get connected to the software. And I push create workspace. Okay, this is the workspace. Now we need some schematic windows and also some display windows to see what we are doing. So first, let's create a new schematic. We click on this icon, cell 1, create a schematic, push it, and we wait a little bit. Here's the schematic window. Okay, so here we have a palette. We have simulators, sources, and components. We just want to go very simple so we don't have a electric circuit. What we are going to implement based on this tutorial, first we want to put a LC here and then connecting two ports to it, and then making a symbol for it, basically. Okay, so to do that, there are two options. First, you can go to lumped components here, and then it will show you resistor, inductor, and capacitor. Okay, or if you know their name, or else you can type it in this palette. For example, L. You type it, you press enter, and it will bring you an inductor. Then you type C and you press enter, and here it is. So how to get rid of this cross on the screen? For example, when you enter, you have this cross. It shows where to put it. You just left click here, and then if you don't want it anymore, you press escape here. So it goes away. All right. How to rotate this? You click on it, you hold Control key, and you push R. Okay, this is the negative, and this is positive. For this job, we don't care about the polarity, but in general. Okay, then we need to connect these two components to each other. Here is the wire, insert wire. You click on this side, left click, and then you click left click on this side, so they're connected. How to get rid of this cross? You press escape on your key. Right now, this capacitor, this side is connected, this side is not, it's float. Okay, so what we need to do is we need to connect the ground to it, right? Here is the ground. Okay, and this part of inductor, I'm gonna connect a little bit wire like this too. Okay, and also a little bit wire here. Okay. Next step is we need to put two ports, port at input, port at output. Okay, based on here, based on this tutorial. Okay, it's needed for later simulation. How to put ports here? This insert pin, these are ports. So you click one here and Control R here. Okay, This is the pin. So in a hierarchy structure, you will have access to this if you make a symbol from these ports. It doesn't show inside, but you will have a symbol for it with 2 ports. That's what we want. Okay. The next step is we want to go parametric for each of these components. I don't like to have the values written exactly here. So we click on var here, VAR, we click and we put it on the screen and we push escape window. Okay, then L. Okay, how much is L? So let's take a look on the value of L here. In this project that we have, the value of L is 0.3 nanohenry. Okay, and the value of capacitor is 0.12 picofarad. So I will put these 2 values there. So I will put L1 here. I typed L1 and I typed L1 here and I put the value 0.3. So look at it. L1 is 0.3 nanohenry. So the unit is here. So here is a common mistake. If somehow when you are putting some values here, you delete or remove this nano, then it gets confused and your result will be bad, different, weird. So pay attention to that. The next step is putting some value for C. I will put C1 here, I'll type C1 here. Then you're not able to type it here. You need to double click on var and you type C1 and you put the value. How much was it? 0.12, I think. Yes. And so you shouldn't push OK now. It will replace this one with L1 that you put. You need to push add. So you see now you have 2 values and then you push OK. So I have L1, C1, each one a good value. Okay. What's the next step? The next step is we want to put this voltage step and we want to put a resistor as the resistor of our source, which is 50 ohm. So in microwave and RF standard is either 75 ohm or 50 ohm. In US mostly we use 50 ohm. Okay. So what we're going to do is we want to put this source and this resistor as our source and internal resistance of our source. And then one schematic doesn't have any load resistance, and the other schematic has a load resistance. Okay, we want to compare these 2 results. But right now, I'm going to save this. You click on this icon to save it, and then close it. Okay, that's all. Then I'm going to open a new schematic window, cell 2, create a schematic. Okay, I want to change the size of my window, and then I want to drag this schematic and draw on my window, the one that I have here. Okay. Then once you draw it, once you you hold your mouse key, you drag it, and then when you see your new window, you just leave the left mouse key, and then it will ask you if the cell does not have a symbol here. Would you like to generate? Push yes. And then you don't need to change anything here. It's dual, the symbol type, and you push OK. Okay. So this is what you have. These 2 pins, if you remember. So if you click on this and then you here click push into hierarchy, it will show you what is inside of that box. That's the symbol that you made for this inductor and capacitor. Okay, so you push hierarchy, you see what's going on inside, and then if you want to go back to a higher level, you click pop out. Here we go. Okay, now we want to put the source and the resistor here and also here. Okay, so let's do it. So to do that, we need to pick up a, based on the tutorial, it says you need a V1 volt step with this much rise time and which this much internal impedance, 50 ohm. Okay, so we again click on this palette, we click on sources, and we go with time domain sources. And then we find the step one because we want to apply a step voltage to it. Okay. And also we need to add a resistor as internal resistance of the source. So we click, we type R, and then we click, this is our R, and then we rotate it, we leave it at 50 ohm. As you see, the default in ADS is 50 ohm because the default is we are using 50 ohm impedance in RF and microwave in US. We connect this pin to this resistor, and then we connect the ground here. Okay, and then we save. We don't forget to save. Okay, this is connected. Now let's check. The tutorial says put rise time of 0.1 nanosecond and the voltage must be 1 volt. Okay, the rise time of 1 nanosecond, 0.1. And let's put the delay also. Let's put the delay 0.5 nanosecond delay. Okay. How about the other side? The other side, once let's leave it open, and once let's connect it to a 50 ohm. Okay. But now, so we need more stuff to be able to simulate this. First of all, we need a simulator because as you see, there are different types of simulators here, different simulation types. So you need to tell the software what type of simulation you want to do on this. We want to do a transient simulation right now. Okay, so we click on simulation, transient here. And then we pick the transient simulator here. It says, when do you want to stop your time? It's 100 nanoseconds, it's too much. Let's go with, for example, 5 nanoseconds, okay? And also, the next step is, okay, so we have our simulator, we have our circuit, but where are you going to, what are you going to plot? That's another question. You need to mark, for example, you want to plot voltage at this node and voltage at this node, or later on current of this branch and current of this branch, okay? Okay. So to do that, we need to add a name here. So you click on name here, you push OK, and then you see this cross, you put the cross on this wire and you click on your left key on the mouse. And if you say, what's the name? I want to call this V1, okay? And once you call it, then you click on the screen, okay? So you see V1 is here. The same thing here, V2, okay? You click on the wire, you put name as V2, and then you click on the screen. This is V1, this is V2. And then you push escape key. Here we go. Okay. This is what we have now. Again, you save it. Now it's time to simulate. Easily, you click on this simulate key. And you wait. After the simulation is done, a new window will pop up. Here it's still simulating. We wait more. Okay, it's done. Okay, this is our plot window. Okay, so what we're gonna plot is this V1 and this V2 at the same plot. So to do that, you click on this icon, rectangular plot, and you left click here, and you see V1 and V2, right? So you click on V1, you click on add, then you click on V2, you click on add, and then you push OK. Here's what we have for now. You see, this is the time we define simulate from 0 to 5 nanoseconds. This is the delay that we gave 0.5 nanosecond to the source, and this is a little bit overshoot, you see. Okay, now, okay, let's check here. So we have a 50 ohm resistor here, and then we don't have any load here, right? The load is open, right? Okay, so the next step is we add a resistor here and see what happens. So a 50 ohm resistor based on the tutorial. I click here. Okay, this is the resistor, and then I simulate it again. Now, you see the voltage is right now, after a transient time, the voltage is constant to 0.5 volt. Why? Because this is a voltage divider, right? So you have a resistor here. We are looking at this point basically after a small period of time. So it will the voltage at the output will be constant, and so at the end of the day you will have 1 volt at input that is divided by 2 because you are looking at this. This is a voltage divider, and inside there are some components that there are inductors and capacitors that they are important only in the transient time, not when the voltage is stable. All right. So in the tutorial, it says change the rise time. For example, you can change it and check the results again. And then the tutorial says, so we want to add more sections to this. Okay, this is only one section that we have. Okay, the whole goal is to simulate a transmission line, and so a transmission line can be modeled by a lot of these inductors and capacitors in series, basically cascaded. That's what we want to implement. Okay, so what I'm gonna do in my next simulation, I want to just copy this, Control C, or let's see what's the best way. Yeah, so let's save this, okay, and then file, save as. Let's take this to another cell, cell 3, and push OK. All right, I want to have 10 of these back-to-back cascaded. Okay, so I need to delete this line. I just Control C, I copy, paste. 2, 3, 4, 5, 6, 7, 8, 9. What happened to the last one? 10. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Okay. Then we connect these cells to each other. Okay. And then here we have V1. We don't have V2 here. So we put the name here. V2. Okay. And we save it. And then it's time to run it again. So we click on simulate. And we wait. Okay, the simulation is done. We just need to plot our voltages again. Okay, so the same thing, add V1, add V2, and here we go. This is our voltage, and it's at 0.5. When we have the resistor at the output, right? If we don't want to have it, you just click on it. You want to make it not to work, either delete it with delete key you have on your keyboard, which I recommend to do that, or you click on this, which deactivate the resistor. Okay, this makes the resistor deactivate. Don't use this one. It will make it short. This will make it open. This one will make it short. Okay, that means if you make the resistor short, the ground will come through this wire and will be connected here. Okay, that you don't want it. You just want to make it open. So to make it open, you use this. And how to get back? So again, you click and it goes away. Okay. All right. You have 10 of them. Now you can make a cell that has all of these 10 cells, okay, and put the symbol for it. Okay. So how to do that? To do that, I will delete this part, and I will delete this part and this part. Okay. I am going to put another pin here. Where is it here? Pin 1 and Control R. Control R, pin 2. Okay. I save this as cell 4. Okay. I save it and I exit. I make a new one, cell 5, create a schematic. And then again, I have 10 of them in cell 4, right here. So I just want to drag and draw and drag and draw here. It wants to make a symbol, yes, make a symbol, dual, okay, here we go. Okay, now if you want to simulate, again, we need to bring all the sources and simulator and everything, or I will go and copy from the other cells. You just save this one, okay, then I go, let's see where we can find it here, for example. So I'm gonna copy all of this, Control C, and then I'm going to paste it here. Okay, and I'm going to delete this, and I'm going to put here. Okay. All right. So how many we have inside of this? Basically, we have 10 of the cells, and each cell had 10. So that means we have hundreds of stages of inductors and capacitors. Okay. We run it again. Okay, and then again, we want to see V1, add, and V2. Here it is. Okay, we can change also the stop time to increase the time or decrease the time. We can change the rise time to picoseconds. For example, let's say 1 picosecond. What happens? That's what it happens if you change it to pico with 100 stages of or inductors and capacitors. Okay, we save this window and also this window. So feel free to play with changing the values. You don't change the value of resistors either. You open or short it. Okay, this and dark is 50 ohm. So either we put it or we don't put it. When we put it, it's 50. And when it's open, we simulate it. This is when it's open. Okay. Okay. Control Z to get back to normal, and I save it. Okay. The next step is sometimes. So this one was transient simulation like this. In transient simulation, you will see what happens in a very specific period of time in your simulation, and if it's gonna be stable or not. Okay. But sometimes we want to see, for example, the frequency response of the network. It's a filter or anything. Okay. So what you need to see there, if you have worked with other softwares like LT Spice, so you need to put an AC source here, 50 ohm, and run it again, right? Then you plot V2 over V1, and you will see different values. Okay. So what I'm gonna do here is I want to file, save as, to cell 6, and I want to start AC. We have cell 6. Okay, let's send 7, cell 7. Okay, now we are at cell 7. Okay, let's save there. I don't want the transient simulator, so I delete it. Then I look up for AC simulators. We come here, simulation AC. I click on it. I click on AC. I click here. In AC simulator, you see the frequency response, right? So you see the x-axis based on frequency, and the y-axis, the parameter you want to see. The start time is 1 gig. The stop time, let's put it 60 gig. And the step size, make it as small as you can. 0.01 gigahertz. Okay. Okay. Now I need to change this source because that's for transient analysis. Okay, so I click on it, I delete with my keyboard, and then I go on sources here. What sources we have? Frequency domain. Let's see. Yeah, we can find VAC from frequency domain. So sources, frequency domain, VAC. Okay, we put it here, and then here is our VAC, and here is our simulator, and it's ready to be simulated. I save this and I run it. Okay, here's our window. Now, you might be asked to plot different things. For example, amplitude, magnitude of V2 over V1. You need to also report, you need to have access to current here. So we need to put a current probe there and differentiate of V2 over V1. Okay, so first of all, let's, for example, plot let's plot magnitude of V2 over V1. So we type here mag parenthesis V2 over V1. It's sensitive if it's uppercase or lowercase, so don't forget that. Click add, Okay, so this is magnitude of V2 over V1. V2 is here, V1 is here. Okay, then you might be asked to plot phase of V2 over V1. So we type phase of V2 over V1. Push add. Okay, this is the phase. Okay. Then let's go and put some current proofs here to check the current. Okay. Okay, to put current proofs. So we go on proofs here, proof components here. I probe. I will put one probe here, just there, and another one here. Okay, you see now the current probe is shorted. So click on this part and delete it. Now current goes through this and it comes down. And here it's shorted too. So delete it. Now current goes here and comes. Change the name to I1 and I2. Okay. So I1 is here and I2 is here. There it is. Let's simulate it again. Okay. There shouldn't be any change on this part because it's a short circuit, basically, to prove. And then now we can see I1 and I2 as well. So let's plot, for example, magnitude of I1 dot I over I2 dot I. That's what you see the current. Okay. Let's plot magnitude of V1 over I1. So magnitude of V1 over I1. Add. Okay. I forgot to put dot I. Okay. If you type something wrong, you double click on this. And then on trace expression, you can find it. So I need to add dot I. Okay. Here we go. This is magnitude of V1 over I1. Then you might need to plot magnitude or phase, doesn't matter, magnitude of V2 over I2 dot I. Add, okay, here's what you see, 50 ohm. When you're plotting V over I, basically you're plotting the impedance, right? Input impedance, output impedance. Okay, next, let's plot a differentiate of V2 over V1. You might be asked for that. Differentiate of magnitude of V2 over V1. Add. Okay, that's what you will see. And so that's the way you follow the document for your project on the website, and then you try to plot different parts. You might be asked to change the value of capacitors, inductors. You put a resistor here, the load, you take it off, and doing more simulations. It depends on the project that you have. That's all. If you have a question, you can send me an email, and I will reply back to you as soon as possible. Have a good day. Bye.